Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to talk about titrations. In particular, I'm talking about how how to do a strong acid, strong base titration problem to figure out what the pH is, and keeping in mind the pH curve. And so in this problem here, you're given a 50 milliliter sample of a 0.200 molar NaOH solution, and you're going to titrate that with a strong acid. So NaOH is a strong base. You're going to titrate it with nitric acid, which is a strong acid. When they react together, they're going to react completely. And so we'll be able to calculate the pH after adding some of that acid. So they want to know what is the pH after adding 30 milliliters of the HNO3, and then what is the pH at the equivalence point. So, first thing we need to do is we need to calculate, if we're going to do part A, we need to calculate the amount of moles of hydroxide ion in the strong base solution. So we're going to have to use the mils here. We're going to convert that to liters, 0.50 liters, and we're going to take the molarity. So we have 0.200 moles per liter, so 1 liter. And so that's going to cancel out, and that's going to give you 0.1 moles. So you've got 0.1 moles of OH. So this is 0.100 moles of OH minus in solution. So that's the moles of OH. The next thing you need to do is calculate the amount of moles of the HNO3. So you take the molarity here, and you got 30 mils. So here we're going to convert that to liters, 0.030 liters over 1. And you're going to then use the molarity to calculate the amount of moles of HNO3. So here you have, again, same molarity, 0.200 moles per 1 liter. Liters cancels out, and in this case, you're going to get 0.006 0.006 moles. So 0.00600 moles of H plus. So this number of moles is going to cancel out the same amount regarding the hydroxide. So if you do your stoichiometry table, right? So here, if you do the stoichiometry table, we have OH minus plus H plus goes to H2O. And so what's going to happen is, if we balance the equation here, this is already balanced. So when we put in our HOH minus, we'll have, at first, before we had 0.100 moles of the OH, and we had 0 of the H plus. And so we're going to add, remember, so this is the first part when we're doing our stoichiometry tables, before we add, and then when we add, we're not adding any OH, but we are adding H plus, so we're adding 0.00600. And so after adding, this is going to completely react with the same amount here. So we're going to subtract out 0.00600 here. So then this becomes 0. Let's see, it's going to be 0.09400 for the OH, and then we're going to have 0 for the H plus. So this is the new concentration of our OH concentration of our sample that we're titrating. And so the next thing we're going to need to do is, I made a mistake here. So this should be okay. So I just realized my mistake. So I made a mistake here. This should be 0.0100, and so that's going to change this to 0.100, and then this is going to be 0.4, so 0.004. I forgot 0 moles. So this is the number of moles that we have left of hydroxide ion. So what we could do is then we could take the POH. This is the OH concentration. So if we take the negative log of this, take the negative log, and we get the POH of 1.3. So the POH is equal to 1.30. And then because pH plus POH is equal to the pKw, which is 14, and then we subtract this out from 14. So then that's going to give us, so pH is plus 1.30 equals 14. So then pH is going to be equal to 12.70. So that would be the pH after adding 30 milliliters of our 0.2 molar HNO3 solution. Okay, so for the equivalence point, so you got to remember, for a strong acid and a strong base, notice that they're at the same concentrations, okay? So same concentrations of your strong acid, strong base, strong acid. So at the equivalence point, that's, you have to understand what the equivalence point is. That's when the number of moles that you had in the base is now equal. You've added an equal amount of moles of your acid to neutralize completely the base that you had. So in that case, because it's a strong acid, strong base, the only thing that's left over is a salt. All of the H plus is gone, all of the OH minus is gone. There's no extra H plus, there's no extra OH minus. So it's all gone. So all you have is water and salt. And so in that case, the pH would be 7. Because the only H plus ions that are in there is because of the autoionization of water. So that would give you H plus concentration equal to 1.0 times 10 to the negative 7, which gives you a pH equal to 7. Okay, and that's because it's a strong acid, strong base. And the salt, because the remaining cations and anions, that are left in the salt come from strong base, strong acid, they're not going to affect the pH of the solution. So you don't have to worry about that. I hope this was helpful. If you like this video, please like, share, subscribe, hit the notification bell, put a comment in the comment section. Thanks for joining me, and I'll see you next time.